Hi folks, we're gonna talk now about one poster. It was presented a few years ago in the International Symposium on Equine Reproduction. This poster talks about stallion semen freezing using a special freezing extender. Let's see the poster that we're gonna talk now. This is the poster that we're going to talk about. It was presented in the International Symposium on Equine Reproduction 3 years ago. So, this poster, we're going to study or we're going to understand deeper each part of it. The title, the introduction, the methodology, the results, and for sure, the conclusion. The idea is to be able, in a short video, to understand the main points, the main highlights, the main message delivered by this study. Let's go to the first part. This is the title. Novel lyophilized extender maintain stallion semen characteristics during freezing, but do not need frozen shipment or storage. It was published by myself, Dr. João Rafael, Dr. Maria Munhoz, Dr. Valdemar, and Dr. Professor Gustavo Carneiro. What it says to us? Well, stallion semen cryopreservation is an important procedure for conserving genetic results having a relevant role in the horse industry. Also, distribution of commercial extender is hard, is difficult, due to the necessity of freezing maintenance. The aim of this work was to compare the after-thawing spur results of two commercial frozen extenders available worldwide, C1 and C2, with two new freezing extenders, both lyophilized, Star and MX3, which can be kept at room temperature up to 1 year. So, why it's important? The first part, well, frozen semen is very important. It's used for artificial insemination, and it's a very easy and cheaper way to keep the semen for a long term and also to spread the semen of one expensive, important, relevant male to many places in the world. Only by this way, the semen can survive for many years. Otherwise, it will not be possible. So, the semen freezing and the quality of the semen freezing is important. Great. Second point. What about this issue that is mentioning in this introduction about this differentiation of some freezing extenders that has to be kept in as frozen in comparison to those that can be kept, the new one that can be kept at room temperature because they are lyophilized? Well, due to the composition of the freezing extenders, they have egg yolk, they have milk, and many other things. It means that if you thaw and refreeze, the quality of those normal, let's say that, freezing extender, the quality will not be the same if you do that. So you have to keep them frozen. However, when you have a long shipment, when you have to transport it and you have to keep in your car, it is hard to keep them frozen, mainly because they have some cryoprotectants. So it means that the freezing temperature, it's even lower than the normal one. So it means that has to be really cold to keep them frozen. And it can be a nightmare. And if you use them, the semen quality will not be that good after thawing, so it's always a risk. So the idea is to compare them with a new kind of lyophilized extender that can be kept lyophilized at room temperature. So it means that you don't have this headache of keeping them in the fridge all the time, in the freezer all the time. So, but it's easier, yes, for transportation, yes. However, what about the quality? Is the quality as good as the normal ones? This is the aim of this study, to figure it out if they are easier to use, but also as good as the classic one. Let's see the methodology of this study. This is the methodology. 28 stallions were used. One ejaculate of each was collected. The ejaculates were diluted with Equiplus, it's a milk-based extender, until the concentration of 100 million cells per ml. Great. After that, each ejaculate were split in 4 tubes, and these 4 tubes were centrifuged at 600 G force 20 minutes. After that, the supernatant was removed, and the pellet of each one was resuspended with 4 different extenders: C1, C2, star, and MX3. Great. The concentration was 200 millions per ml. After that, the semen was loaded in straws, 0.5 straws. And each tube had the straws split in 2 groups. One group was submitted to a freezing protocol in the freezing curve 1, and the other part, freezing curve 2. The difference of them is the freezing curve 1, the straws were exposed 20 minutes to 5 degrees, after that 20 minutes to the nitrogen vapor, and after that they were submerged in the liquid nitrogen. In comparison to freezing curve 2, this one, instead of 20, it was 60 minutes at 5 degrees, then 20 minutes at nitrogen vapor, plus nitrogen itself. After that, to compare them, both groups were thawed in water bath, 37 degrees, 30 seconds. And the semen was evaluated by 3 vats using a microscope, and the total motility was checked. So, now you know the methodology that was used. 28 stallions, split ejaculate, 4 freezing extenders, 2 freezing curves. And all of them, after thawing, let's see the motilities that we got. Results. This is the general total motility. So C1, C2, star, and MX3 for extenders and 2 freezing curves. When you compare here, you're going to see, pay attention to these letters. They have the same letter for all of them. So it means that when you compare the extenders itself in each curve and the extender in different curves, you're going to see that due to the same letter, there is no difference. Maybe it will try to push you to believe that there is no difference and you can use anyone. But it's not true. If you pay attention, you're going to see that the individual variations is quite high here. So this is why you don't have any difference. But when you go deeper and you start to analyze each stallion, for example, stallion 14, you're going to figure it out that in stallion 14, you had the better result, total motility, 52.5, in the combination of star and freezing curve 2. When you compare with the others, you're going to see that the others have or had a lower motility. Let's go to the Stallion 3. The Stallion 3 did not like the same combination as the Stallion 14. For this Stallion, it's a way better to use freezing curve 1 with MX3. Look at that in comparison to the others. What about the Stallion 22? Well, Stallion 22, look at that. It's a different preference, different recipe for this one. He likes most C1 in freezing curve 2, 63.7% in comparison with the others. So, what we can get in the first sight with these results? The stallions are different. The stallions have different combinations, different preferences. We cannot standardize and use the same protocol for all of them. It is clear, we could see that, and you have a huge difference in the results. So if you want to maximize your results, you have to pay attention to that. But the aim of this study was mainly to compare the lyophilized extenders with the normal extenders. So let's see what we got. This is the comparison. You have 4 colors, 4 different extenders. Freezing curve 1, freezing curve 2. Pay attention that you have in red and yellow the lyophilized extenders, and in purple and gray the other ones. In the freezing curve 1, you have, or we have, 14 stallions reaching the better motility using this extender. 6 with this extender, and the other 6 and 2. When you go to the freezing curve 2, using the same stallions, remember that the best extender for this freezing curve 2 was the purple one. 14 stallions preferred this extender in the freezing curve 2. 6, 4, and 4. So, when we compare in general freezing curve 1 and freezing curve 2, and put in the same group lyophilized extenders and frozen extenders, we can see in the freezing curve 1, we got 20 out of 28 stallions with better results with lyophilized, and 8 with normal extenders. In the freezing curve 2, 10 lyophilized and 18 normal extenders. However, it's very important to mention that we did not get only one extender, doesn't matter if it's lyophilized or not, with the best results for all 28 stallions. It did not happen. So it means that despite of the difference in the freezing curves, you have to pay attention to each stallion preference. It is very important to keep in mind, we have to understand that stallions are different, again. And for sure, you can use any freezing extender and after thawing you're going to have some motility. But the target has to be to reach the best motility possible after thawing. And in this part we could see clearly that you have difference. You cannot say, I'm gonna use only this extender, doesn't matter if it's lyophilized or not, on only that freezing curve. Doesn't matter. You have to have a freezing test to figure it out the best combination for each stallion. Let's go a little bit further. In this part is compared the freezing curve 1 with freezing curve 2, trying to figure it out if it was possible to say, okay, this freezing curve is better than that one. And look at that, comparing the maximum, the best motility of 28 stallions, 13 of them preferred, despite of this extender used, preferred the freezing curve 1, and 15 the freezing curve 2. What it means, you cannot just choose one freezing curve and establish that as your protocol. Cannot be like that. For sure, again, you're going to have some motility. However, it will not be the best one. Let's go to the conclusion. High motility after thawing might indicate good sperm metabolism and suggest the maintenance of cellular structure after freezing. Considering the results, lyophilized extenders are promising candidates to be included in freezing protocols and fertility trials worldwide, mainly if considered their easier storage, reasonable price, and simple freight requirements. So, we could see that you can have very good motility. You have to play with these lyophilized extenders and the freezing curves with different stallions and figure it out, again, the best combination. They are easier to transport, easier to keep, less headache, and you can reach a very good motility after that. Thank you so much. This is the conclusion that we got out from this paper. Thank you. See you in the next video.